morning. This is for KAP Thursday, March 25th. This is the homework. Just check it on your own, and then we'll get into the lesson. All right, so yesterday we talked about like inequalities. Yes, you'll remember like less than, greater than, all that good stuff. Big thing about inequalities is that it's comparing two things. It's comparing one number is less than a number, one is greater than a number. Okay, y'all good with that? We did this discovery lesson yesterday in my class, right? We did this yesterday with the graphing it on the number line. We multiplied, we divided sometimes, and then we came up with like a rule. Do y'all remember what that rule was? Yeah, say it louder, Alexander. Yes, when you multiply or divide them by a negative number, we have to flip the inequality sign. Y'all remember that? So it's in our notes again today, but I'm sort of going to breeze through it because hopefully we remember that. Okay, so these are the notes. Starting at the top, I'm going to sort of skip over. I'm not going to do a lot of these graphs because I don't think they're completely necessary, but just see if you agree or disagree with me. Do we agree that 5 is less than 9? Yes, I'm going to put a check mark. Do we agree that 11 is greater than 6? Yes, okay, those are both true statements. It says, now let's add 3 to each side. So if I added 3 and added 3, again, you don't have to take full notes. You can sort of just watch along. Actually, I'm going to do down here, plus 3, plus 3. What would that new inequality be if I added 3 to both sides? It would now be 8 is less than, is that statement true? Yes, so again, I'm just going to check it. I'm not going to bother graphing these because I don't think it's completely necessary. If I add 3 to the other one, the new inequality would be is more than 9. Very good. Are we agreeing with that statement? Yes. So that's just showing that I can have a true statement, add to both sides, and it stays true. Okay, so when I add or subtract, like over here, when I know I'm going to be solving these inequalities, I don't have to do anything special. Okay, so looking over here, they've thrown in a variable. I'm trying to figure out all the values that x could be. What are some values it could be? It could be 2 would work. What else? 1. What else? 3 would work. All those decimal numbers, all those negative numbers, those would all work, right? But I'm not going to sit here and say x could be this number and this number and this. We don't want to do that. We're just going to write an inequality saying that x just could be any of these numbers that are less than this. Could it be 4? No. It could not be 4 because that would be equal and it doesn't have the line, but it could be anything less than. Okay? So the way that we show that inequality is sort of like an equation when we solve it. We want to split it at the inequality sign, and then I want to get x by itself. So I'm going to do what to both sides? I'm going to subtract or add negative 5. Subtracting is just easy. Okay, cancel out what I can cancel out. Bring down what I need to bring down. What is it going to read as? X is less than 4. Okay, and let's go back. Isn't that what we said? We said that it could be 3, it could be 2, it could be 1, it could be 0, all those numbers. But again, this includes all those decimal points that we don't want to write out and all that stuff. Okay, so this is like the solution. We call it a solution set because it's a set of numbers. It's not just one solution, it's many numbers. Okay, and then we can graph this as we learned how to do yesterday. Okay, so what number do I for sure need on my number line? I can have 0, but I for sure need 4 on there. Okay, it's always good to have 0, but you don't have to. And Miss Lytle always likes to put a number on each side. Okay, so again, can it be 4? 4 is not less than 4, and then I can't plug it in up here either. So is it going to be an open or closed dot? Open, and then it's all numbers to the left, because left to the left. 3 would work, so 3 is less than 4. You can plug that back in, so like a number that's less than 4 is 3, and again, we said that 5 plus 3 would be less than 9, so that works out. Okay, this is showing you all the possible answers that could go into that equation. Okay, so let's just do another one. X minus 11 is greater than 6. What would I need to do to both sides? Add 11. that new inequality would read. Then 17, very good. Okay, so again, 16, 17, 18, open or closed, and to the right. Okay, nothing too crazy. Y'all go ahead, do 1 and 3. If you finish early, do number 2, pause and play when you're ready. Yeah, let's tell Miss Lytle what she needs to do. On the first one, I need to subtract from both sides. My new inequality will read very good. Okay, I don't have room for the graph, but close circle to the right, right? Because it'd be greater than, so 4, 5, 6. Okay, on the next one, I need to do what to both sides? What does that say? So I need a -2. Okay, so this is what I was saying, -5 over -2. Remember that throws me off, so I write it side by side. -5 minus 2. What is that really going to be the same thing as? Very good, and that would get you -7. I know sometimes we still get stopped up and we get like 3 or -3. Write it sideways and then add the opposite. It truly does help me every single time. So that new inequality, n is less than or equal to -7. Close dot and to the left. Okay, so again, addition, subtraction, there was nothing fancy that I needed to do. Just make sure you bring down the inequality and solve it like an equation. Multiplication and division is where there's sometimes you keep it the same, sometimes you flip it around like we were talking about. Okay, so we're going to go through this real quick. Y'all just tell me if it's true, not true. Is 24 less than 40? Yes, that is true. What about is, okay, we're a little low. We're going to, give me a second, I'm going to erase that. I'm going to put the check mark off to the side. It says, let's divide each side by 4. So I'm going to divide by 4. 24 divided by 4 is 6. It's already there. 40 divided by 4 is 10. It's already there. They brought down the inequality sign. Is 6 less than 10? Yes, that is still true. Okay, so I divided, nothing changed. Okay, but let's see what happens when there are negative numbers. And we already know from that ELT lesson that what's going to happen, we're going to need to flip the inequality sign. But let's just go through that. So we're starting with this inequality. Is 24 less than 40? Yes, I agree with that. If I divide, I'm sorry, this is going to be really small, but if I divide by -4 on both sides, 24 divided by -4, signs are different, negative wins it, and that would give me a -6. Other side, 40 divided by -4, those signs are different, so again, negative wins it, and that would give me a -10. They brought down the inequality sign. Is -6 less than -10? No, this is false. Wrong. You are incorrect. So to fix that, I would flip the sign, which they did down here to make it true. Okay, so that's just redoing that. That was when I divided by a negative. So let's see what happens if I multiply by a negative. Starting with 4 is greater than 2. Am I starting with correct things? Yes, I am. Let's multiply by, well, first it says to multiply by 2. That would give me, real quick, 4 times 2 would be 8. 2 times 2 would give me 4. I think you multiplied that one by 2. It's fine. Don't worry. Okay. Is this statement true? Yes. Okay. I know the setup is a little weird, but we're going with it. Now, if I start with the same inequality, 4 is greater than 2, is that true? Yes. Let's multiply them both by -2. So times -2. You literally can't see what I'm writing, but just know. 4 times -2, -8. 2 times -2. Is this statement true? No, because they just brought down the inequality sign. This is false. To fix it, I need to flip it. Okay, so maybe you want to write flip. So you know to flip. Okay? So we know now, and again, we saw that in our ELT lesson. So when we're solving it, we just need to keep that in mind. Before I even get to the steps for solving it, just looking at this equation, what numbers would make x a true like this? What values could I put in for x? 2. What else? 1. What else? 3. Could I put in 3? No, anything less than 3. So again, to write that solution set, I don't want to sit here and write, all the decimals that could be in fractions and negatives. I'm just going to write my solution set. To do that, I want to get x by itself. What is happening? It is getting multiplied. I want to undo it with division. So divide both sides by 4. That new inequality would read 3. Did I need to flip the sign? No. Why not? There's no negative. I'm not dividing. It's a positive. Okay? Again, I can graph. I think we're pretty good with the graphing. Over here, x is getting divided by 8. So to get rid of the division, I would need to multiply both sides by 8. Sorry if this is really small. It prints pretty well, but okay, cancels out. That new inequality would read 24. You good with that? X is greater than 24. Again, don't need to flip it. But what's happening in the next one? There's negative. So I should have like a car alarm going off, fire alarm, veto, mayday, mayday, alert. I need to do what? I'm going to need to flip the sign. Okay, to get x by itself, I would need to, what was that? Ooh, tricky. They're getting multiplied. I would need to divide. It's going to keep tripping you up. Don't worry. Y'all are not the only ones making that mistake. That is a lifelong hassle. Adults make that mistake. I make that mistake. We're human. Oh my God. It's I need to divide by -4. Divide by -4. Okay. New inequality will read x. Oh, I'm hearing both of them. Okay, remember, we're dividing by -4. X is greater than. We have to flip. X is greater than -3. The way this is set up, I'm pretending it's the same problem down here. I'm supposed to do this incorrectly, but I don't want to do it incorrectly because I think we already get that we don't want to. Okay, so just sort of ignore this. All right, so over here, it's getting divided by -8. So I need to multiply by -8. I need to multiply by -8. Alert. I need to flip. So maybe do that first. Flip your sign. I'm going to be left with Gucci. Okay, cool. So again, the big idea when multiplying, I'm going to abbreviate, or dividing, you need to flip. You must flip. When multiplying or dividing by what kind of number? A negative. Very good. Yes.
Top one is negative. What is the negative x?
If you had a negative x, so if negative x was greater than 16, and you're saying what would you need to do? Okay, so let's talk through that. So guys, that's not x, that's a negative x. So you could do the flippy thing that we talked about with equations, but I like to think, what coefficient could I write there I could put a 1. So it's -1x is greater than 16. What would I need to do to get x by itself? Divide by -1. That would flip the sign, and it'd be -16. So it's doing the opposite of this, the opposite of that, and the opposite of that. If you think of like the flip that we did during equations, like when you had -x, you want to do the opposite, you would have to do the opposite of everything. That's what ends up happening. Okay, but so y'all do those next 3 problems, actually the next 4. Just practice solving with the word problem. Pause if you're at home and play when you're ready. All right, for the first one, 110x, what operation is happening? It's getting multiplied, so I undo it with division. Yes, let me make this just a little bit bigger. My eyes are having so much trouble. Okay. I'm going to divide both sides by 110. On this side, it's going to cancel out. I have x. Do I need to flip the sign? No. What's going to happen here? It's what? Not negative. It's going to be a decimal, or I could leave it as a fraction. Nowhere does it say that I have to write it as a decimal and or a fraction. But it is division. But remember, if I do 80 over that, how could I simplify that fraction-wise? Divide by 10. I can divide by 10, and then it turns into 8/11. That's a fraction. I could just leave it like that. Nothing says you have to turn it into decimal, but you could. So you could say it's 8/11, or you can divide. I bet a lot of people did 80 divided by 110. What do you get? It's a weird number. It's like 0.72727272, right? So that means it's a what kind of decimal? Repeating, okay? So you get 0, 0, you get 7, 2, 7, 2. How do we not sit here for forever? Put the line over which number? Is it just the 2? It's over both of the digits. If it's 0.72 with it over this, that's saying the 2 is repeating. I have to put it over both of them to show that both numbers are repeating. Just a little review. Yes, ma'am. Yeah. So if you put it in the calculator, if you put 1/3 in the calculator, or let's go with 2/3, because that's 0.6. Usually when you put it in the calculator, it will put a 7 at the end because it's rounding. In the calculator, it's rounding. It doesn't have an option to show a repeating sign for the ones that y'all use. But it's saying it does go on forever, but a calculator just automatically rounds. Fun fact. Okay, but it should be 0.6 repeating. All right, looking at the next one, it's getting divided by -6, so I need to multiply by -6. And what is happening in our brains? Yeah, it cancels out. I need to flip. That's the big thing. Alert, alert. I'm multiplying by negative, so it's going to be a less than or equal to. Okay, what's on either side? What's over here? Less than or equal to 42. Let's finish it and then we'll go back and graph. Okay, what's happening to x? It's getting multiplied. I need to divide. So divide both sides by 7. X. Do I need to flip it? Why not? I'm not dividing by a negative. There's a negative up here, but I'm not dividing by it. So I leave it, and then that's going to give me -8. Very good. Okay, let's go back and graph just real quick, because especially the first one. If I put, I'm going to leave it as a fraction because that's friendlier. What whole numbers could I put on either side? Huh? Well, 7/11ths, but I want a whole number. Huh? It's 0 and 1. It's between 0 and 1. Think about that, because 8/11ths is the same as this. It's more than 0, but it's less than a whole. It's not 11/11. That's just me being tricky and making sure you're like, oh yeah, that makes sense. Open or close circle? Open. It cannot be equal to, and then it's going to be all values less. Okay, the next one, I'm going to have 41, 42, 43. Open or closed? Closed and to the left. last one, -8. Ooh, be careful, it's negatives. Open or closed? And to the left. Yeah, all of them are to the left. Okay, last one, a word problem just to have fun with it, because it doesn't give me the inequality. I have to write it myself. Joanna's parents give her $10 per week for lunch money. She cannot decide whether she wants to buy or pack her lunch. If lunch costs $2 at school, write and solve an inequality to find the maximum number of times per week she can buy her lunch. Okay, so what can we come up with? We want an inequality that represents this whole situation. $10, $2, how many times she's buying her lunch. What do you think? What are some parts of it at least? Less. Is that what you said? Yeah. Okay. Less than or equal to. Okay, so yeah, we have what we can spend has to be less than 10, or it can be exactly 10. Okay, how do we calculate how much we spent? This is coming from how many lunches we're buying. So how can we calculate that? Okay, so let's call X the number of lunches we buy. Number of lunches. Okay, I heard someone say it. It would be 2X because each lunch costs $2 and you would multiply. Is that sort of making sense? Yeah. Again, remember on a test, you're going to be given those answer choices, so you'll probably be able to see it. You'll be like, oh, it's this one because it's multiplication. It's harder to write it yourself, but we want to challenge ourselves. So I wrote, now I need to solve. To both sides, I would need to divide both sides by 2. X is, very good. So she can buy her lunch 5 or less. Gucci? Cool. So for those of y'all at home, there is partner practice. There's an activity that Face-to-Face is doing. Katie, it's a little harder for you to do. So you can work on that partner practice and then the homework worksheet. That's the partner practice. And the homework, oh, that's the key to something. Don't forget, there's a DLA tomorrow and then a test review that you can work on over the weekend when you super duper miss your teachers. Okay, thanks, bye. Bye.